Alright, so we are going back to limits, continuity, and differentiability. What's nice about ending with L'Hopital's is that we go right into limits again. So you have limits, continuity, and different. Right in front
You
of
had
me.
20 minutes to do this before she started.
We only have limited time.
Literally, limits.
Oh my goodness. Concepts to know for Unit 1. So these are the concepts you need. I'm so sorry for this tiny.
I was like, come on. Let me get my magnifying glass.
Do you want me to read since I'm big?
No.
No, it's fine.
I mean, I'll be able to figure them out.
I think you could send me the
Oh, sure. So you need to determine limits from a graph. You need to know the relationship between limits and asymptotes. So what are examples? We have two types of asymptotes. What types of
Vertical
asymptotes?
and horizontal.
That is correct.
Raise your
We
hand
can
out.
compute limits
Not funny.
algebraically. So that's when we did the factoring, canceling. When you factor and you cancel, what does that create on your graph?
Hole. That's right. That's right.
That's the whole reason I did that.
And then what do we remember this as being?
Definition of a derivative.
Correct. So definition of derivative is f prime of a at a limit for f of a plus h minus f of a all over h. So I should recognize from this that this is the derivative of cosine at,
Pi,
yes,
which is 0. Negative 0.
Yeah,
the
I
derivative
missed,
of cosine.
Negative sign.
Yeah.
I missed
So
the
it'd be
Khan Academy
zero.
yesterday.
Oh.
I was so mad.
And then it ends with L'Hopital's, which is what we just ended with.
Yeah.
So you have the existence of a limit at a point. A limit exists from the left. A limit exists from the right. If the left-hand limit equals the right-hand limit, then the limit at x approaching c is equal to L. So the left-hand limit and the right-hand limit may not equal each other. If they do not equal each other, the limit does not exist.
True that. But that's how it's broken.
I mean,
Still right.
I mean,
No, we gotta keep going through.
Fine, so you don't have to write on this page anyways. The limit from the left is following the linear line down. You can see that the limit from the left and the limit from the right are not equal to each other on that graph. The limit from the left is approaching 1. The limit from the right is approaching like 1.4.
This is
So-
piecewise, right?
Yeah.
Exactly. So piecewise graphs
Equation continues.
are not always continuous. So those are the graphs that we have to check for continuity. Continuity, however, implies what?
Differentiability.
Unless,
It's a corner.
Or cusp.
Hole.
It's constant jump.
vertical asymptote.
and another vertical one.
Oh, there's 4.
Tangent.
Tangent.
There we go, baby.
Well, vertical asymptotes discontinuity. That's
Yeah,
what I'm
vertical
talking
asymptote.
I was trying to come out with vertical.
Yeah,
Yours
I
is
know.
coming out.
Wait, what was the fourth one?
So
Vertical
it's
tangent.
I got
vertical
that.
tangent,
Cusp,
Cusp,
corner,
cusp, corner,
hole.
Hole would be discontinuity, so they're actually
Yeah.
jump.
Not a
No,
hole.
that's also discontinuity.
Yeah, discontinuity as a whole is the 4th one.
No. It would be. What the hell is that?
oscillating.
I don't feel like that was the fourth one.
Yes,
That can't be
Good
it.
chance.
I would have remembered oscillating.
That's when you do the squeezy theorem.
Oh, no.
That's where it literally like looks like this, and you have to squeeze the
But I feel
function.
like that was differential. Like, why would that not be different?
Because you can't find a particular point. So the DNE here is at 1 because you have what type of discontinuity? jump. The DNE at 2 is not, or sorry, it's not DNE at 2 because even though you have removable discontinuity, the left-hand limit and the right-hand limit still equal each other. So also the limit at 2 exists. Continuity. Left-hand limit must equal the right-hand limit. It must be defined. So that eliminates your holes. That eliminates your jumps. If the limit of x approaches a of f of x equals f of a, then you have a continuous limit. Yeah.
So the limit can equal a whole, but it can't be differentiated on that range.
It can't be differentiated.
So a limit
So-
can exist and still be not differentiable?
Correct. So like in this example here, the limit as x approaches 2 exists.
But it's not.
However, we cannot find f prime of 2.
But you
Because f prime of 2 is a whole,
and
it
you
does
can't
not
find
exist.
F prime of 1 to 3 either then, because of that discontinuity.
We can find f prime of like 1.5.
But we'd have to break it up. Like if we
Yeah.
were doing as a slope of a line, you couldn't do that.
Correct. But yeah, you could find f prime of 1.5, you can find f prime of 2.5.
Yeah.
Or that leads into something having a left-hand derivative or a right-hand derivative. So remember, we could find like the left-hand derivative where it wasn't continuous beyond that, but you could find the derivative getting infinitely close to it.
Yeah.
Okay, so continuity is on an interval, if we need it to be. If it is continuous at every point of the interval, then it is continuous. Intuitively, a function is continuous. It's continuous if its graph can be drawn without ever needing to pick up your pencil. So, continuity does not imply differentiability. However, differentiability does imply continuity. So if a graph is differentiable at every point, or you're told it's twice differentiable, then that means it is continuous on both its original and its derivative. So having twice differentiability makes it continuous on f and f prime. The definition of the derivative comes from or after continuity. We have two forms. You have f prime with the limit of h approaching 0 of fx plus h minus f of x all over h. And then you have the original, what? No, not yet. IROC and AROC are, well, AROC is average rate of change.
That's f of b
Which
minus
is
f
slope
of
of
a
the
over b
steep
minus a.
And IROC would
With the
be,
derivative at a point.
yeah, so it could be IROC. This would be the I. Because this is the derivative at A, where that's the derivative everywhere. What?
Talking about the country.
No, I was at him.
I don't know,
But
honestly,
it's
I don't
fucking
think Blaze could point out Iraq.
I couldn't. Listen, that was 7 years ago, no, 6 years ago. I wish we still had.
Actually, it was last year in World Culture we went over.
I wish we still had a class that would go over literally every
Right.
country that's
Right.
later, but I mean, I think we're on getting country.
I don't know if I could point to a general area,
Iraq.
but I don't know if,
There's really only two options on
There's
it.
Iran and Iraq. I could point to Saudi Arabia, I could point to.
I'm just saying, like, I guess I would see based on size. Because, like, the Middle East doesn't have very many small countries, but.
Blank map of world.
Or we're in calculus.
Continuity and differentiability. Differentiability implies continuity, but not necessarily vice versa. If a function is differentiable at a point, then it is continuous at that point. And you could conversely say if a function is differentiable on an interval, then it is continuous on that interval. The converse is not always true. Continuous functions may not be differentiable, It is possible for a function to be continuous at a specific value, but not differentiable there.
I'm thinking my next slide's going to have where it's not, or what type.
No, that's a
No, I
good
have
stuff.
L'Hopital.
Oh, no, yeah. Might be a tomorrow. Actually, tomorrow's very, like, interactive.
I stole it from Lindsay, but I kind of like it. It has like a Quizlet, it has like,
I don't like it, yeah.
like
I
Quizlet.
don't like the easy.
No, I like
Their
it.
reviews are very good, though.
Yeah.
Alright, and then L'Hopital's, which you know, which says you need to be able to get a limit to produce an indeterminate form of 0 over 0, infinity over infinity, negative infinity over infinity, infinity over negative infinity, or negative infinity over negative
Or
infinity.
0 times infinity.
Yes. But then you can like manipulate that, like 0 times infinity manipulates to 0 over 0. It's pretty good on your quiz.
Well, thank you.
Okay. So then that ultimately leads into the questions I have broken down for you. So I have 21 questions, 19 are multiple choice, 20 and 21 are this amount of free responses.
Which is part A.
So that's what we're
We're
going
going to spend the next 45 minutes on whatever you don't finish this homework.
Oh, I didn't sign up for this.
Where is it?
I'm going to hand it to you.